So we use law of sines to find sides that we're missing in right triangles. Well, guess what? We can also use the law of sines to find angles that are missing in triangles. Before we do that, a brief review on how you find an angle that has a particularly given trig ratio. So for example, what angle has a cosine that is equal to 0.686? Normally on our calculator, we have the angle. We do like cosine of 38 degrees, and it tells us the ratio value. Here we're doing that in reverse. So the question we're asking is, what angle, and I don't know it right now, so I'm going to call it x, has a cosine that's equal to 0.686? For this purpose, we have developed inverse trigonometric functions: inverse sine, inverse cosine, inverse tangent. And it uses our inverse notation. So it's cosine with a little exponent of -1. What goes into here is this cosine ratio. And what comes out of here is the angle that has that cosine ratio. So this function answers this question. We'll show you where to find it on Desmos and also on your handheld TI calculators. On your handheld TI calculators, if you look right above the cosine button, you'll see the inverse cosine. On mine here, it's written in blue, meaning I've got to use my second button. So press second, then cosine, and notice it gives you that inverse cosine. Then just type in 0.686. I, of course, 86, and I've got to double check myself. Was it 686? Yeah. And make sure I'm in degrees. Okay, I'm in degrees. And the angle that has a cosine of 0.686 is about 46.7 degrees. So that's what I'm going to write down. And there it is. Now, just to prove to you that it works, if I do the cosine of 46.7 degrees, it's going to be something right around 0.686. There you go. So the inverse cosine gives you an angle. The inverse trig functions give you angle measures. Again, I stress, the inverse trig functions are giving us angle measures. What angle measure has that cosine? Okay, just for practice, would you please evaluate inverse sine of 0.42? I'm going to use Desmos this time, just to show you where things are. So on your Desmos, if you use your functions, they're right here, your inverse trig functions. Make sure you're in degrees. Okay, so the angle that has a sine of 0.42 is 24.8 degrees. And then lastly, just for practice again, which angle has a tangent ratio of 2.633? So that's inverse tangent. And on Desmos, you can just type it yourself too. Tangent with an exponent of -1, and it will know what you mean. 2 point, and I've already forgotten the rest of my tangent ratio, 633. Make sure it's in the parentheses. And that's going to be an angle of about 69.2 degrees. Okay, there you go. With that in mind, let's now go back to our law of sines work. So this time what's missing is not a side length, but it is an angle measure. I'm looking for this angle right here. Now you still need to make sure you have a set of opposites in order to use your law of sines, which we do. I've got the angle y, and then I've got the side y across from it. So sine y over y equals sine of this x that I don't know yet over the opposite side length, which is 19. Sorry, I'm going to keep things in variables at this point. All right, now let's start to fill in what we know. So my y is 116 degrees. My lowercase y is at 42 miles. Sine of x, this is what I don't know. And the side x is 19. Okay, let's get the sine x by itself. We do that so that I can then use that inverse trig function. So this time, just multiply the 19 over. So the sine of x is 19 times the sine of 116 degrees divided by 42. Now this over here, this is just a number. I don't know what number it is. 19 sine 116 divided by 42. Okay, so it's about 0 point that. Now, when you are now using your inverse trig function, it's essential that you do not round things. So what I would say is, leave this just like it looks. So this whole thing here, not rounded at all. The x I want is the inverse sine of this whole thing. So this 0.4 number, but the unrounded version is what's going in this inverse sine function. If I'm on Desmos, it's super easy just to say, all right, would you please do an inverse sine of this? Type it all in like it looks. Okay, so it's going to come out to 23.99, so right around 24 degrees. So the angle I want is about 24 degrees. Okay, then. Yeah, I think that looks pretty good. So the only difference was you still set it up the same way, multiply the 19 over, but we've got this additional step. When I want to find the angle, I then do that inverse sine to finish the process. Let's go again. Please do a quick pause here. I want you to try this yourself and then unpause when you're ready to check things. So I do have a set of opposites. I've got side F and angle F. So sine of F over F. And I've got angle E and side E. The sine of E over E. Okay, put in the numbers that we know. So the sine of 30 degrees over 14.1 kilometers. Whoops, I don't want to write the unit there. Equals the sine of the angle I don't know over this length of 6 kilometers. Get the sine E by itself, so multiply the 6 over. So the sine of E is 6 times the sine of 30 degrees over 14.1. So then the angle I want, to get rid of the sine, you use your inverse sine of the 6 sine 30 degrees over 14.1. Again, I want to stress, to find an angle, that's what your inverse trig functions are for. It's going to tell me what angle has this sine. I'm going to use the handheld calculator this time just to show you how it works. So you can do it in 2 steps here. It's actually not too tricky. I'm going to do 6 sine 30 over 14.1 first. So 6 sine 30 degrees divided by 14.1. So that comes out to be 0.2127. 659, on and on and on. So I'm asking the question now, what angle has a sine equal to this number? For that, I want my inverse sine. And rather than typing all this again, if you look above your negative key, it says ANS. That means answer. It means please use the answer from the previous line. So it's saying please use this whole number. So to get that ANS, press second and then negative, and it'll put that in there for you. So our angle this time is about 12.3 degrees. So E is about 12.3 degrees. And that looks about right. It's a small angle, smaller than the 30. 12.3 seems reasonable. One more time for good measure. I would like you to please pause, unpause when you are ready to check. So I've got my set of opposites. I've got angle S, and then across from it, I've got side length S. I don't have angle R, but I do have side length R. So let's fill in what we know. The sine of the 78 degrees over 30 kilometers is the sine of the R angle, which I don't know, divided by the 28 kilometers. Multiply the 28 over, and we have the sine of the angle R is 28 sine 78 degrees all over 30. Okay, so then, I've already forgotten what my numbers were. 28 sine 78 over 30. So 28 sine 78 degrees divided by 30. So I'm trying to answer the question, what angle has a sine equal to 0.91293777607? So inverse sine of that answer tells me my angle is about 65.9 degrees. So heading back, that means that my r then is the inverse sine of this, which is about, and of course I've already forgotten, 65.9 degrees. So the big takeaway, you still need to make sure that you have your opposites in order for the law of sine to be helpful. But to find your angle, when you're finished, make sure that last step is to do an inverse sine. It's those inverse trig functions that get you the angles you want.